Alright, good morning guys. We're going to go ahead and start up on our lesson today. So, in problems 1 through 4, write an equation of the line that contains the point -4, -3 and meets the given condition. So you can pause the video if you'd like and try this warm-up real quick, and then we can go through it together. Alright, so with this problem, we want to find the line that is perpendicular to the y-axis. So the first thing I'm going to do is I'm going to go ahead and draw my axes and draw the point -4, -3 on those axes. So here we go. Here's -4, -3. Now, we want a line that is perpendicular to the y-axis. Now, the y-axis is our vertical line, so our line that's perpendicular needs to be horizontal. Now, if it's going through the point -4, -3, that means that it's going to cross through the y-axis at -3, 0, -3. Further, it is perpendicular, so it needs to have a slope of 0. Which leads us to our answer of the equation y equals -3. Next, we want a line that is parallel to the y-axis, that goes through the point -4, -3. So if it's parallel, it's going to be a vertical line as well. It'll never touch the y-axis. So therefore, it needs to be a straight line going straight up right through this point. So what that means is that it's going to create the line x equals -4. Again, this does not have a slope. It is an undefined slope because it is a vertical line. And in fact, this blue line is not even a function because it fails the vertical line test. So this blue line here is the line that is parallel to the y-axis and passes through the point -4, -3. Next, we want the line that is perpendicular to the graph of y equals 4x minus 3. So first off, we see that's perpendicular. We know perpendicular lines have opposite reciprocal slopes. So if my slope is 4 here, then my perpendicular slope would be -1/4. Again, you change the sign. It was positive here, now it's negative, and you flip your fraction. So if it's 4/1, it becomes 1/4. So that is our slope. Now, to find our y-intercept. So currently we have the equation y equals mx plus b. And we've only found m so far. M is -1/4. So I need to find b. Now I have the point -4, -3. So I'm going to plug -4 in for x, -3 in for y. So I now have -3 equals -1/4 times x, which is -4, plus b. From here, I'm just going to solve for the b variable. Once I solve for b, well then I'll have b and I'll have m, so I'll have my equation. So to solve for this, -1/4 times -4, the 4's will cancel and I'll be left with +1. So -3 equals 1 plus b. From here I subtract 1 from both sides and we're left with b is equal to -4. Which leaves us with our equation as y is equal to -1/4 x, again that slope doesn't change, minus 4, our y-intercept that we just found. So that is our equation. As for our final, we want the line that is parallel to the graph of y equals 4x minus 3. So this time, the slope will remain the same. We're going to do the same thing with the rest of the numbers, though. So again, this is x, this is y for -4 and -3. So we have y is equal to 4x plus b. I can plug -3 in for y, -4 in for x, and solve for b. This will give us -3 is equal to -16 plus b. If I add 16 to both sides, we get b is equal to 13. Which leads us to our final equation as y is equal to 4x, because the slope does not change, plus our y-intercept, which we just found, as 13. So there is our work for our final line. And again, this green line and this red line here, these are also perpendicular lines. So both sets of lines that we found, the black and the blue, and then the red and the green, those are perpendicular to each other, as we can see on the graph here. So, with that being said, we're going to be covering 2.12 today, equations of lines. Your learning target today is I can write equations of lines. So this should be a bit of review for you guys, especially from Algebra 1, but again, it's been a while since you guys have seen it, so let's go ahead and jump right in. The first example that we have is to write an equation of the line containing the points 7, -3, and 4, 1. So, to get started on this one, we're going to go ahead and put it into point-slope form. If you don't recall what point-slope form is, let's go ahead and write it out. All we need for point-slope form is a point and a slope, which we do not have our slope currently, but we can find our slope through 2 points. So point-slope form is written in the form y minus y1 equals m times x minus x1, where x1, y1 is a point on the line, and m is the slope. So, the first thing that we need to do is find slope. Well, to do that, I'm just going to go ahead and label this as x1, y1, this other point as x2, y2. And again, it doesn't matter which one gets 1 or which one gets 2, as long as they're grouped together. So x1, y1 needs to be together, x2, y2 needs to be together. So from here, we can use our slope equation, which is m is equal to y2 minus y1 over x2 minus x1. This will give us 1 minus negative 3 over 4 minus 7. Whoops, sorry. So I'll just go ahead and bring that up. This will give me positive 4 because a negative with a negative right next to it turns to a positive. So that gives me positive 4, and then 4 minus 7 is negative 3, so our slope is negative 4/3. Now that I have my slope, I can go ahead and choose either point to replace x1 and y1, and I'm going to use my new slope to replace m. So now I can either use, if I use 7, negative 3 as x1, y1, that would give me the equation y minus negative 3. Let me start here. That way we can see that double negative. Y minus negative 3 is equal to negative 4/3 times x minus 7. Now, if we see that double negative, we need to simplify that down. So that would change to y plus 3 equals negative 4/3 times x minus 7. This is our equation written in point-slope form. Now, if I chose my other point, 4, 1, as my x1 and y1 variables, that give me y minus 1 equals negative 4/3 times x minus 4. Both of these are the same exact line, just using different points on the line. So they're equivalent answers, and either one is acceptable. All right, let's go ahead and move on and see all the different types of linear equations that we'll be using. So, go ahead, take a second, write these down if you need to. I'm just going to go ahead and start listing through them. So these are all 3 different forms of linear equations, things that you guys should know from Algebra 1 in years past. The most common one that you guys have used is slope-intercept form. That's just y equals mx plus b, where m is your slope and b is your y-intercept. Now it's important to note that anytime that you just see x and y in here, any of these, where it's just x and y, not x1, y1, but just x and y, x is always the independent variable, our input, y is always our dependent variable, our output. Now we would use slope-intercept form if we're given the slope and the y-intercept. That's the time when you want to use slope-intercept form, when you have both of those things. Next up is point-slope form, another form that we've used in the past, probably not as much as slope-intercept, but it is used quite often. That form is y minus y1 equals m times x minus x1. Again, m is my slope, and x1, y1 is a point on the graph. Now, you would use point slope if you have a point and a slope, or if you have 2 points. Another good reason to use point-slope form is if you're further away from your y-axis or your x-axis. If you're really in large numbers, in the thousands, 10,000s, stuff like that, you want to use point-slope because you're not going to see that axis, you're not going to see the axis or the intercept there. So it doesn't really make sense to use a form where you would need to see the intercept. So point slope is often used for really large numbers or really negative numbers as well. And then lastly, we have standard form. That's written in the form of ax plus by equals c, where a, b, and c are all real numbers. Now, oftentimes this is used to find both the x and the y-intercepts. So it's very easy to be like, okay, well, if x is 0, then that'd give me my y-intercept, and then I could just solve for y here by using y is equal to c over b. and then I plug in 0 for y to find my x-intercept. So this is how you'd use standard form to find those intercepts. As soon as you have the 2 points, you can create your line. Lastly, we have a vocabulary term down here that we'll be using in just a minute, the median of a triangle. So a median is a segment from the vertex of a triangle to the midpoint of the opposite side. Now, when you're trying to think of median, you guys are getting close to the age where you're going to start driving soon. So when you're driving down the road, typically you'll see this middle section in the road that has like trees in it, or it's just some concrete or something like that. It separates both sides of the road. That is called a median because it splits the road down the middle. And medians go to the midpoint. So medians also split segments down the middle. So that's a good way for you guys to think about medians, is that a median when you're driving is the middle of the road. It's what separates the middle of the road. And a median within a triangle separates the segment of the triangle into 2 equal parts. So let's go ahead and try out our median problem. Find an equation of the median to segment AB. Now, if it's the median to segment AB, that means that it's going to go from point C, from the opposite vertex, to the midpoint. So this point will split perfectly in 2. Now I'm going to go ahead and give my midpoint a name. I'm going to call it point D. And my midpoint may not be perfect because, again, I don't see the grid lines. I'm not sure exactly where it's at quite yet. So at this point, I can go ahead and create my median from point C to point D, which is what this blue line here is. This is our median. Now, at this point, now that we know what our median looks like, we need to go ahead and find the equation of this line. So to do that, the first thing I should do is I should find out where point D is located. I already have point C labeled, but point D is not. So to find out where point D is, well, it's the midpoint of segment AB, because again, the median splits it right in the middle. So D has to be the midpoint. So I need to first find the midpoint of AB. So this is my midpoint. Now, if you guys recall, the midpoint formula is just x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Well, looking at this, I'm using points A and B, so I have negative 3 plus 9 over 2, and I have 2 plus 4 over 2. Well, negative 3 plus 9 is 6 over 2, and 2 plus 4 is 6 over 2, which will give me the midpoint, point D, being at 3, 3. So point D's point is 3, 3. Now that I have point D, I have 2 different points on line CD, on my median. So I can find the slope of this line. So let's go ahead and find the slope of CD. So slope of CD. Using y2 minus y1 over x2 minus x1, we'll get m is equal to 12 minus 3 over 5 minus 3. That'll give me 9 over 2. So that is our slope, 9 over 2. From here, we're going to go ahead and use either point, point C or point D, to plug it into our point slope form. So if I choose point D, well, then I'd have y minus y1, which is 3, equals m, 9/2, the slope that we just found, times x minus x1, which is 3. That's if I use point D here. So where D is x1, y1 will give me this green equation. If I use point C, then 5 would be x1 and 12 would be y1. So that would give me y minus 12 is equal to our slope, 9/2, times x minus x1, which would have been 5. So again, either of these answers is correct in finding the equation of the median to AB. Now, could you have put this in slope-intercept form? Absolutely, but you don't necessarily need to in that case. So let's go ahead and try out another one. This time, we're going to find an equation of the perpendicular bisector of AB. So a perpendicular bisector splits the segment in 2 because it's bisecting it, and it's intersecting at a 90-degree angle. So the main difference here is that our perpendicular bisector isn't necessarily going through point C. it's just going to be perpendicular to line segment AB. So let me go ahead and draw this up first. First off, I have my midpoint here because it's bisecting it. It's cutting it into two equal pieces. Now, if we look at this triangle, it's the same exact triangle as our previous problem. So our midpoint is still point D at 3, 3. That has not yet changed. Now, at this point, we're going to go ahead and have our perpendicular bisector here, and it's going to intersect at 90 degrees. So we need to find out what this equation is. So to do that, the first thing we need to do is we need to find the slope of AB, because if it's a perpendicular bisector, the slopes will be opposite reciprocal of intersecting lines. So if AB is perpendicular to our perpendicular bisector, they need to have opposite reciprocal slopes. So our slope of AB, well, that will give me m is equal to y2 minus y1 over x2 minus x1. 4 minus 2 is 2. 9 minus negative 3 is 12. 2 over 12 is 1/6. So our slope is 1/6. From here, we know that our perpendicular slope will be the opposite reciprocal of 1/6. Well, the opposite would be negative, and then if I flip my fraction, that will just give me 6. So my slope is going to be -6. Now at this point, I still have a point that goes through this perpendicular bisector. That point is our midpoint, 3, 3. So I can use that to solve this line. Y minus y1 equals m times x minus x1. Again, I have my slope and I have a point, so I'll use point-slope form. This will give me y minus y1, which is 3, equals m, which is -6, times x minus x1, which is 3. And this is our answer to the equation of our perpendicular bisector to segment AB. And here it is a little bit more cleaned up for you guys as well. All right, next up, we have the definition of altitude. So altitude is a line segment through a vertex and perpendicular to its base, the side opposite the vertex. So I'm going to go ahead and draw a quick diagram of this. So our altitude will always go from a vertex to the opposite side, and it will always intersect in a perpendicular fashion. So it's not like the perpendicular bisector where it doesn't necessarily go through a vertex, but the altitude must go through a vertex and be perpendicular. So that means that it's not necessarily bisecting it, it's just going to intersect at 90 degrees. Now, a good way to remember altitude is the true height of the figure. It's similar to when you go to a doctor's office. When you're going to a doctor's office and you're measuring yourself, well, the doctor's measuring you or the nurse is, you're not going to lean against the wall. So here's the wall, I'm in the doctor's office. I'm not going to lean against the wall and be like, okay, measure me, my head's right here. I'm actually going to stand perpendicular to the wall with my back flat against it so that they can measure my actual height. So altitude needs to be perpendicular. You need to be standing straight up for the altitude, and it needs to go through a vertex because it's measuring the height of the figure. So if it's not at 90 degrees, you're not going to find the true height of the figure. It must be standing perfectly straight. Much like at the doctor's, you need to stand straight up when they measure you, because if you're not, then it's not a good measurement. Same thing happens here. All right, let's go ahead and try out one of these problems with altitude now. So find an equation of the altitude to AB. So again, we're dealing with the same exact triangle, ABC, same numbers and everything. This time we're finding the altitude to segment AB. So my altitude's going to connect from the opposite vertex to segment AB. So it needs to go through my triangle. And again, when it goes through, the main thing that needs to happen with this segment is that it needs to be intersecting at 90 degrees. It needs to be perpendicular. So let me go ahead and draw it real quick. Here is our perpendicular altitude. And from here, we need to do a couple things. The first thing that we need to do is we need to find the slope of AB. Because again, I already have point C up here. That's the point that we're going through, the vertex. I don't have the intersection point for AB. However, I do know that they're perpendicular, so they're going to have opposite reciprocal slopes. If we recall from the last problem, we got the slope of AB equaling 1/6, which means that our perpendicular slope, again, will be -6. Again, opposite reciprocal. I still have a point that goes through this line, 5, 12, point C. So I can use that as x1 and y1. This will lead us to point slope form because I have my point C, and I have my slope, -6. So we have y minus y1 equals m times x minus x1, which will give us y minus 12, which is y1, is equal to m, which is -6, times x minus x1, which is 5. And that is the equation of this altitude. And again, we can see that right here. Y1 is 12, x1 is 5, and then our slope is -6. All right, let's go ahead and move on. Next up, we're just going to have a nice, easy problem here. Find the rise and the run between the marked points on each graph. Then find the slope of the line. So this should be our basic algebra. Rise and run is just depending on how much we're going up or down and left and right on the graph. Rise deals with how much we're going up and down. Run deals with how much we're going left and right. Much like I can't run up into the air, I can rise through an airplane. However, I can run on the ground. So that's a good way to think about this. I can run left and right. I can't run up and down. I can rise up and down, but I can't rise left and right. So looking at this, we can see very clearly that to get from one point to the next, we need to go down 6, so my rise is -6. I need to go right, and that's in a positive direction. I need to go right 3, so that's a run of +3, which means our slope is rise over run, so -6 over 3, which is equal to -2. All right, next up. Write an equation parallel to the given line through the given point. So it's going to be parallel to the line y equals 9x plus 4 and through the point 2, 7. So there are a couple different ways to go through this, and I'll show you guys a couple different methods to use. Again, it's totally dependent upon the problem that you're doing, whether it tells you to solve for it using a point slope form or slope-intercept form. It depends on the problem itself. So first off, this line is going to be parallel to y equals 9x plus 4, which means that the slopes will stay the same. And it's going through the point 2, 7, so this will be x1, y1. I have a point and a slope, so I can use point slope form. So y minus y1 equals m times x minus x1. Y minus y1, which is 7, is equal to m, which is 9, because they're parallel lines. Whoops, I'll just bring it up. Which is equal to m, which is 9, because they're parallel lines, times x minus x1, which is 2. So this is our point slope form. This is a perfectly acceptable answer. If they asked for it in slope-intercept form, the only thing that you need to do is solve for the variable y. So to do that, I distribute the 9 through the parentheses, giving me 9x minus 18, and then I just add 7 to both sides to get it away from the y. So -18 plus 7 will give me -11. So y is equal to 9x minus 11. These two are the exact same line. So you can use either answer, and it would totally depend on the actual question that's being asked. But if it doesn't tell you, then you can choose either one. So keep that in mind as well. All right, next up, write an equation parallel to the given line through the given point. So you can pause the video right now and try this one out on your own if you'd like, and then we'll be going through it afterwards. So for this problem, first off, we notice that we have the equation 5x plus y equals 2. This is in standard form. So we need to go ahead and put it into slope-intercept form so we can see our slope clearly. To do that, I subtract 5x from both sides. The 5x's cancel. I'm left with y is equal to -5x plus 2. Now again, this is going to be a parallel line, which means that my slopes will remain the same. It's going through the point 2, 3, so this will be x1 and y1. And then from here, I can just plug it in. So y minus y1 is equal to m times x minus x1. Plugging in for these variables, we have y minus 3 is equal to m, which is negative 5, times x minus x1, which is 2. Now, sometimes I may not even need to put it into point-slope form. They may just say, okay, put it into slope-intercept form. And I can go through this whole process of putting into point-slope and then converting it, or I can just put it in right away. So to do that, we have y is equal to mx plus b. This is slope-intercept form. I know my slope. My slope is negative 5, so y is equal to negative 5 times x plus b. I also have a point, x1, y1. So I'm going to plug 2 in for x, 3 in for y, and solve for b. So this will give me 3 is equal to negative 5 times 2 plus b. Now I just need to solve for the variable b. 3 is equal to negative 10 plus b. Adding 10 to both sides, we see b is equal to 13. So our answer would be y is equal to negative 5 times x, again the slope has not changed, it's parallel, plus 13, the y-intercept. So again, both of these answers are correct. One is in point slope, one is in slope-intercept. All right, let's try another one. Next up, we want to find a line that is perpendicular to y equals 1/4 x plus 3 and going through the point 4, 1. So go ahead and pause the video and try this one out if you'd like. Keep in mind this time it is perpendicular though. All right, so looking at this, we're trying to find a line that is perpendicular to the given line and goes through the point 4, 1. So if we have perpendicular slopes, they are opposite reciprocal. So if my slope is 1/4 right now, my slope will become negative 4. Again, I flip my fraction, which becomes 4 over 1, and then I take the negative sign from it. Now, at this point, I still have 4, 1 for my point. So that's the point that we're going to go through. If I want to go ahead and I want to put it into slope-intercept form, y equals mx plus b, I'll go ahead and start plugging in my different variables. So this will give me 1 is equal to negative 4 times x, in this case x is 4, plus b. And we're just going to solve for the b variable, because once I have that y-intercept, I can just plug it back in, and we'll have our new equation. So will give me 1 is equal to negative 16 plus b. I add 16 to both sides, and we get b is equal to 17. From here, I just plug this back in, along with my slope, and we have our answer as y is equal to negative 4 times x plus 17. Further, if I wanted to put it into point slope form, this would have been y minus y1, which would have been 1. Again, I can see that right here. 4, 1 is x1, y1. So y minus 1 is equal to m, which is negative 4, times x minus x1, which is 4. So again, both of these answers work for this specific problem. And here they both are. All right, we have another one coming up. Next up, we want a line that is perpendicular to 2x plus 5y equals 3, an equation in standard form, and it's going through the point 2, negative 3. So go ahead and pause the video and try this one out, get as far as you can, and then we'll go from there. All right, so the first thing I want to do is I want to go ahead and solve for the variable y, because I want to see what the slope is. Because if I need to find a perpendicular slope, I first need to know the slope. So to do that, I go ahead and I subtract 2x from both sides. This will leave me with 5y equals negative 2x plus 3. From here, I divide both sides by 5, and we get y is equal to negative 2/5 x plus 3/5. So this is the line that we're trying to be perpendicular to. So if it's perpendicular, I need to take the opposite reciprocal of my slope. So the perpendicular slope is, if it's negative 2/5, I flip my fraction, and I take the opposite. So if it's negative, it becomes positive. So my slope is positive 5/2. Now, at this point, I can either put it into point slope or slope-intercept form. I'm going to go ahead and start with slope-intercept form. So y equals mx plus b. I know that I have the point 2, -3, and I could plug that in for x and y. I have my slope as 5/2. I could plug that in for m. From there, we just need to solve for b. So I have -3 is equal to my slope 5/2 times my x value in my point, which is 2, plus b. Well, at this point, I'm left with -3 equals 5/2 times 2, 5/2 times 2, the 2's will cancel. So -3 is equal to 5 plus b. From here, I subtract 5 from both sides, and we get b is equal to -8. I plug this back in along with my slope, and we'll have the equation y is equal to 5/2 x minus 8. That is one of our equations. If I put it into point slope form, then x1, y1, that will take over the point 2, -3 for my variables. My slope stays as m, so we have y minus y1, which is -3, is equal to m, which is 5/2, times x minus x1, which is 2. And from here, we need to simplify if we see those double negatives. So this will give us y plus 3 is equal to 5/2 times x minus 2. And again, these are our equations. These are the equations that we want to have as our final answers. Here's the work once again so that you guys can see it a little bit easier as well. All right, next up. Find the measure of angle ABC. So please pause the video, try this one out, and then we'll try it together, go through it together. All right, so for this one, looking at this angle, we have 83 degrees. We're trying to find the measure of angle ABC, so we're trying to find angle X here. So if this is 83 degrees, well, I know that vertical angles are congruent. So if this is 83, then this is also 83 degrees. Now, looking at the angle relationship between this new 83 degrees that we found in red and this x degrees, they are same-side interior angles. And if we recall, same-side interior angles implies that these angles will be supplementary. So therefore, we can say angle ABC plus 83 degrees equals 180 degrees. Subtracting 83 from both sides, we see that the measure of angle ABC is equal to 97 degrees. So that is our answer for this problem. All right, next up. Line CD is perpendicular to the graph of 2x plus 3y equals 8. If C is equal to 1, 4, find the equation of CD. So again, these two lines are perpendicular to each other. I have a point that lies on line CD, so I need to find my slope to get started. So we know that our slope will be the opposite reciprocal of whatever the slope is in 2x plus 3y equals 8. So we first need to find that slope. So I'm going to go ahead and solve my equation, 2x plus 3y equals 8. I'm going to solve it for the variable y. So I subtract 2x from both sides, left with 3y equals negative 2x plus 8. And I divide both sides by 3, giving us y is equal to negative 2/3 x plus 8/3. So again, we're worried about the slope here. Our slope will be perpendicular. So therefore, our slope is equal to positive 3/2. Positive 3/2. Because again, opposite reciprocal slopes if it's perpendicular. So you flip your fraction, you change it from you change the sign, whether it was positive or negative. Now that we have this perpendicular slope, we're going to go ahead and we're going to use our point to write our equation in point slope form. So we have our equation as y minus y1 equals m times x minus x1. I can go ahead and plug in. 1 will be x1, 4 will be y1 for point C. So we now have y minus 4 is equal to m, our slope, which we found out to be 3 over 2, times x minus x1, which is 1. So this is our equation in point-slope form. I'm going to go ahead and also write it in slope-intercept form. To do that, I distribute through the parentheses. So we have y minus 4 equals 3 over 2x minus 3 over 2. From here, I'll add 4 to both sides. And just for the record, 4 is the same as 8 over 2. So since I'm dealing with a fraction over here, I'm just going to add 8 over 2 to the other side, because 4 and 8 over 2 are the same. So add 8 over 2 over here. This will give us y is equal to 3 over 2x plus 5 over 2. And that is our equation in slope-intercept form. So again, both of these equations, whoops, let me go ahead and redo that. Both of these equations, one in point-slope form and the other in slope-intercept form, these are the acceptable equations that we can use for this problem. All right, we got one final problem to do, so let's go ahead and try this out. Write in point-slope form an equation of a line that goes through point C and is parallel to line AB. So, looking at this, we have AB here, and we're going to be parallel to it. So it's got to have the same slope as AB. Further, it's going through point C, so we'll use point C as well. So it should be parallel. So let's go ahead and start up on this one. First off, we need to find the slope of AB. So the slope of AB. To do that, we can use y2 minus y1 over x2 minus x1. This will give me 3 minus 1 over 16 minus 2. 2 over 14 will be that answer, and reducing this fraction down, we get 1/7. Further, it's going to be parallel, so this is the slope that we want to keep. Next, I'm going to go ahead and label my point C as x1, y1, so I can plug it in, I can plug it into my point slope form. So I have y minus y1, which is 12, equals my slope m, 1/7, multiplied by x minus x1, which is 4. So this is an acceptable answer. Now, if I wanted to go ahead and I wanted to write it in slope-intercept form, well, then I just need to solve for y. So to do that, I distribute the 1/7 through the parentheses. Gives me y minus 12 equals 1/7 x minus 4/7. From here, I add 12 to both sides, and 12 is the same as 84 over 7. I just made it into a fraction. To do that, I did 7, my denominator, times 12 to get 84. So I add 84 over 7 to both sides, because again, this is the same as 12, and that will give me 80 over 7 for my y-intercept. So that gives us the equation y equals 1/7 x plus 80 over 7. Again, either answer is correct. It depends on the problem that they're giving you and which things are blank, whether it's y1, m, and x1, or whether it's just m and b. All right, so that is it for today's lesson. Thank you guys so much for watching. If you have any questions, please let me know. Other than that, have a great rest of your day and take care. I'll talk to you later.